Hello, Hazelwood Year 11. I hope you're all doing well. Wednesday, we've made it halfway there. So, this week, 2 weeks to go. So, well, a few more actually, but we're nearly there, aren't we? So, we're going to look today at paper 2 and designing algorithms. I think this is the topic that gives most people the greatest amount of concern. So, the aim today is to make sure that you've got the tools that you need to be able to answer the algorithm questions. Please do introduce yourself in the comments. Do say hello so I know you're here. I will gladly introduce you. So let's crack on and have a look at designing, creating and refining algorithms. So this roughly is about 35% of paper 2 where you're going to have to do some coding. However, there are really only a couple of structures that you need to worry about. And let's get through a few of those today. And hopefully this will help you. Let's do a quick quiz first of all. I think I can see there are 2 of you there. So could anyone tell me, there are 2 people there. Could you tell me what is the answer here? We've got cleaning up data by removing non-standard characters, hiding or removing irrelevant details, checking the user is allowed to access the program, breaking down a problem, hopefully you figure that one out, to access the breaking down a complex problem into smaller parts, repeating elements of a program, and converting one data type to another. Would anyone like to hazard a guess as to what they would be? Any ideas? So if you could write in the comments CBDA or BDAE. Any ideas on that at all, what this may be? This was the opening starter in the 2000 and I think it was 19 paper for paper 2. Once we got into it, this was one of the first questions. Any ideas what the answers are here, or which ones can you recognise? Oh, I can see that Dan is there. Well done. That's come through for me. Okay, let's have a look. Dan, how you doing? Daniel, good to see you. So you have got F casting. Let's have a look. F is casting. Oh, I'll use my little thingy-bob here. F is casting. So yeah, you were right. F is casting. So the last one down here is F. Have we got any other ideas? And decomposition, you're absolutely right. So this leaves us, we've got... we've done those 2. What about, which of these is abstraction? Abstraction. Any ideas at all? Oh, you've got D. Okay. B is abstraction. Yeah, hang on. Let's have a look. So, Daniel, you were absolutely right. F, casting, decomposition, B, and C, input sanitization. That's the only one that you've actually got incorrect there, because this bit was good apart from the input sanitization. Almost there, actually. That was pretty decent. So, in fact, the answers are DBAF. So decomposition was D, which you got right, breaking the complex problem down. They will check to make sure you know what abstraction and decomposition are. They always check that. So B was abstraction. So A, cleaning up data entered by removing non-standard characters. So input sanitization, and it's in the same area. If you think about an SQL injection, you can use data validation to make sure the right data is going into your database, and F is casting, which you got totally right. So that is all absolutely outstanding. So let's go on to the next one, which is actually a bit of teaching. So we're going to try and get through as much of this today as possible. Make sure you're happy and comfortable with with the flowcharts. Then look at pseudocode and think about how we can tackle some of these questions. Right. So let's push on. So that's from the specification, by the way, and we're on 212. So we're at the sort of the beginning part of paper 2. Paper 2, 80 marks, and it's not all about algorithms. We're going to cover the IDE, the Integrated Development Environment, next time, which I think is really, really easy. So first of all, easy stuff. What's an algorithm? It's a step-by-step plan to solve a problem. Computer science is all about inputs, processes, and outputs. And think about that when you're doing these algorithm questions, because they will always give a mark for the input, a mark for the output, probably 2 marks for the process, and then they'll be looking at thinking about, can you pick out the construct, the right construct? So even if you really struggle with coding on these 6-mark questions, you should be able to get 3 just by following the input-output formula and then having a crack at what's in the middle. Obviously, leaving a blank page is not going to get you any marks at all. So without spending too long on this, we can see that the input here is going to be a current room temperature, and then we've got the process, which is the temperature set by the user, and the output is when the heating gets turned on. So it's a really simple example there of input, process, output. But we need to be a little bit more detailed than that. Any questions, just let me know. All right, so this one's too simple. I don't want to spend time on this because it's not that helpful. This is, though. So what I'd like to do is to have a look at these symbols that you can see in front of you. And I was just going through a Year 10 paper, which is why I've changed direction slightly to do this today, because the Year 10 paper that I marked for, there was a question on flowcharts, and they gave 4 marks for knowing which of these symbols to use. So that's really, really important. So let's run through these one by one to make sure we're happy with what they do. So first of all, we've got the line hasn't got to have an arrowhead on it, by the way. That's not massively important. But let's have a look at the rest of them. So first of all, we've got a process. A process is simply a rectangle. Then we have the input-output on the top right here. The input-output needs to be a parallelogram. Okay, it has to be a parallelogram. If you use a different symbol, you might not get a mark for it. So when you think about the top and the bottom of your flowchart, there's going to be an input, and at the end of it, there's going to be another parallelogram, which is the output. Okay. And quite simply, if it's not an input or an output, it's either got to be a decision or a process. And a decision might be something like an if statement, a selection, an if statement, where you say, if this is the case, do that. So it might say, has user scored more than 10 points? Is user taller than 1 meter 60? Is user shorter than 1 meter 60? Yes or no? And you have the lines coming out of the diamond box there. And in that Year 10 paper I was talking about, they also did an extra mark for having the terminal, the terminators as they're called, which is the start and end. I mean, it's got to be that shaped box, a sort of rounded rectangle. Okay, so those are the flowchart symbols. Now, I'd like to just spend a minute or two thinking about section A of paper 2. So it's split into 2. You've got section A and section B. Okay, section B, you absolutely have to use either Python or you have to use pseudocode, and I'll come to that in a second. But in section A, unless they tell you specifically to use pseudocode, you could use a flowchart. And many people think that using a flowchart is actually a little bit easier, but the difficulty is that using a flowchart can get quite complicated. And I think the difference between a flowchart and and pseudocode is that you really do have to plan a flowchart. So yeah, just to sort of be really clear, this guy here, the terminal, there was an entire mark just for using that terminator. Okay, the beginning and end. This guy here. All right. The subprogram, this one here, they've never actually used this. You know, doesn't mean they won't, but it's a rectangle with those two little extra lines there, two vertical lines. So this process here, if it's not a decision and it's not an input or an output, it's going to be a process. All right. So that's the key thing. So we've got terminators over here. This is the oval shape, the decisions. The process is your rectangle. The rectangle should have 2 arrows coming out of it, one for yes and one for no. And of course, flowcharts should flow downwards. But I would be really wary of using flowcharts because unless it's a simple problem, you can really easily tie yourself in knots. And if you are going to use flowcharts, that's fine. But I recommend planning it with a few words first. Because what I saw when people have used flowcharts is they write it out once, they get halfway through it and go, oh no, I didn't put in this, this, or this, and then they go back and redesign it. And actually, it takes time to draw these boxes because the boxes need to be fairly neat, or at least the boxes need to be, the symbols, sorry, need to be recognizable as parallelograms, a word that I struggle to say, as diamonds or as rectangles. So that needs to be really clear. So I would have a good look at the question and really consider whether a flowchart is a good idea. Of course, you can get full marks using a flowchart. It's not a problem. And they might even ask you to make a flowchart, so you need to be able to do it. But I've sort of come to the conclusion over many years that flowcharts are not quite as easy as they appear when you're in exam conditions and you've got several sort of different decisions to try to sort of input into your flowchart. So something worth thinking about there. Right. We know what pseudocode is. It's not real code, but it's a form of language that is close enough to code that it gives you an idea of how you might go about programming it. Now, this is what I do want to say. Some of you are excellent Python programmers, in which case write it in Python. Or if you would rather write it in pseudocode, write it in pseudocode. Try to avoid coming across both, using both in the same answer. However, if you realise that you have done it, it's not really a problem. Because pseudocode isn't a real code, no one can argue whether you're using a mix of real code and pseudocode. The point is, you've just got to put across the point you're trying to make. Okay, so don't worry too much, because I know that one of my students, one of my year 11 students this year, had written part of it in pseudocode and part of it in Python, and then crossed it out and started again. And that took him an extra 5 minutes, meant he didn't finish. So make sure you don't do that. If you do a mix, it doesn't matter. But try to stick to one or the other. And of course, Python's probably better, but pseudocode's a bit easier, I think. All right. So there's no strict notation for it. And if you don't get the wording exactly right, it's not a problem. It's just putting across your ideas, okay? And these, of course, are the ideas that you're looking to put across. So first of all, we've got the input, and we'll look at that for the input message, the output message, which is usually print. Well, it's always print, really. We've got the repeat until and the while. These are our two condition-controlled loops. We've got a for loop. We'll look at that in a second. And then we've got selection, and selection comes in two flavors, if then else and case select. But the case select you just need to recognize. So in fact, when you think about it, you will usually get a mark. You'll usually get a mark for this guy. You'll get a mark for this guy here doing an input, a mark for an output. You'll get a mark for choosing the right construct, whether it's selection or iteration. And then if you get it correct and you do everything right, you'll get an extra few marks, okay? So there's up to about 4 marks for just doing input, output, and picking the right construct. And when I say construct, I mean iteration or selection, all right? So those are the constructs we'll be looking at. Excellent. Any instruction occurs like selection, yeah, is usually indented. Indented as in it moves slightly in. So when you do an if statement, the next line below, you indent slightly. And if you don't, they won't take marks off for it because it's not a coding exam. But it is an exam to test whether you understand the principles of coding, okay? Right, inputs and outputs. You're putting something into the system, you're getting something out of the system. And this is how you will do it. So this piece of code, you just got to go away and learn. And just to unpick this, and I'm sure that you've seen this 1,000 times before, but I recommend when you get an algorithm question, first thing is go through it and find and ask yourself the question, is there a user input? It's a form of decomposition that we're doing. Break the problem you've got to deal with into smaller chunks. Deal with the user input, then deal with the variables you might need to declare, then think about the construct, think about the maths you might want to put in there. Is there a div? Is there a times? Is there a greater than, less than, any of that Boolean logic sort of stuff? And then do your output. And if you get that right, even if you get all of the maths wrong in there, you should probably get 4 out of 6 for those questions. And if you're hitting 4 out of 6 for these questions and you nail paper 1, then you're looking at a really good grade. So in this case, we have got the name of the data. In other words, what do you want to call your input? So it could be score, it could be height, it could be whatever you like. It makes no difference. And you would simply put that into here. This is the name of your data, your variable name. You write the word input, and then you stick whatever message you want to appear on screen within those inverted commas. and then ding, you've got yourself 1 mark, okay? So, and that will be in nearly every single one. Sometimes they will have done this for you, and sometimes they just want you to declare some variables. So we'll get onto that in a second. But that message, just go and learn it and write it in there. And all you've got to do is put something sensible in here, like enter A, B, or C. Whatever you want the user to do, give it a sensible name here. And that's it. Okay? Sorry, not give it a sensible name there. That's wrong. Give it a sensible name here. This is where the name goes. So the name of your variable goes here. So we'll call it height or call it score. And then in here, put the message you want to appear on screen. Okay? Simples. That's all you've got to do. Right. Then we've got declaring variables. X equals 0. There we go. X equals 0 means you're making a variable. You're declaring a variable called X, and you're assigning it the value of 0. Okay. So, step 1: is there a user input? Use this piece of code here. So, are you going to ask the user to enter something? Get them to enter it. Step 2: are there any variables? A variable is a box in which you're going to store stuff. They will possibly, or very most likely, ask you, what is a variable? What's the difference between a variable and a constant? Well, a variable may change while the program runs. A constant will not change while the program runs. They sometimes only give you the mark if you say while the program is running. And I guess the logic here is that you could go in and change the value of a constant by just changing it in the code. But while the code's running, a constant doesn't change and a variable does. So that is your variables, which is often an input, okay? Now then, they might use this word here, initialization. I just wanted to make sure you were happy with that. Initialization means that you set the value of the variable to 0. So if they say declare a variable and initialize it, and sometimes, so for example, if they ask you to write an algorithm that keeps a running total, they will want you to declare a variable called total, and they'll want you to initialize it. So that all sounds very complicated. You would write total equals 0. That's it, okay? So setting the value of it to 0. Initialization. Typical computer science, they give it a really fancy word. Make it worth 0, okay? So score equals 0. This here is an example of declaring a variable called score and then assigning its value, which is 0, which is called initialization. So that is that part. Good. And lastly, and I know this is obvious, right? But it's just so important you pick up all of these marks. And then it'll say output to screen, which means print. So write the word print and then in brackets write whatever variable you want to print. And it could be this one plus this one, or this one or this variable divided by this one, etc. Okay, or this one times this one. So you can use the print to output anything onto screen. 3 of you here. Don't be afraid to say hello. Daniel already has. Good to see you, Daniel. You've been a regular, a good man you are. Right, print what you want to output. Boom, nice and easy. All right, so now we get into the constructs, okay? So the constructs you've got to worry about are things like selection, iteration, and sequence. So they will test to make sure, and they call them constructions. And constructs means they're building blocks that you can use to write code. So let's look at sequence first of all. Sequence is the notion that when you run a piece of code, the code runs from line 1 and it runs from line 1 to line 2 to line 3 to line 4 until the code ends. And the code will run in a linear fashion from start to finish. And I know that's bleeding obvious, but don't forget, computers don't know that. So this has been set up so that when you run a piece of code, it starts at line 1 and it runs through to the end. However, there are some ways that you can subvert the way in which the code runs. And think about that's exactly what you're doing when you're doing selection. And selection is our if statement. So you've got sequence, which is the idea that code runs from line 1 through to the end. And then you've got another construct, which is selection. Selection means if statements or case select. I will talk about case select. You might want to use it because it's actually easier, I think, to write code with case select than it is with if statements. But I'm guessing you're more used to if statements because they tend to use them more in the exam. So you're going to use the construct of selection under the following conditions. So far we've said, look through the question, put your pen down, and I would spend 6 marks. You've got 8 minutes on this question. You've got about 2 minutes thinking time. Just think, what's happening here? Oh, okay, so someone's going to input that, then it's going to do that to it, and then it's going to output that, and I need to do this bit in the process. Okay, so I would spend 2 minutes just making sure you're happy with what's happening. 2 minutes well spent. And it also reduces the stress because you think, actually, I understand this question. But you do need those 2 minutes just to get your head around the problem they've given you. And this is computer science. So some of these problems, they're quite challenging. So you have done your user input, and we've shown you the code for that. I've shown you the code for that. You've done your any variables you want to declare, boxes where you need to store stuff. We've talked about the definition of variables and constants. We've then looked at sequence as a construct, line 1 going through to the end. And we're now looking at another construct, which is selection. So you can look at your question and ask yourself the question, is there something in here where there's a decision that needs to be taken with more than one possible outcome? In other words, can you squeeze the word if? Does it say somewhere, so when if the users do this, then do that, or if they don't, they should do this? OneDrive, what are you doing? Go away. Let me get rid of my annoying thing. I don't know why it does this. Go away. There we are. So, and that might be a useful way because you've only got 3 of these 3 different types of construct to worry about here. Well, in fact, 2, because you've got selection and you've got iteration. Within selection, you've got 2 types of selection, and within iteration, you've got 2 types of iteration. But the great thing is, you need to recognize them all, but you only need to be able to use 2. So you're going to ask yourself, is it an if statement? If not, it can only be 2 other things, okay? So ask yourself the question, is there a decision with more than one possible outcome? If it's a child ticket, you pay $8.99. If it's an adult ticket, you pay $12.99. If they're less than 1 meter 40, they don't get to ride. If they're more than 1 meter 40, they do get to ride. So read through the question, you can go, that's an if statement. And just by figuring out it's an if statement, 1 mark, okay? So this is the anatomy of an if statement. So you start off by writing the word, wait for it, if. And at the end of it, you write end if. Easy peasy so far. If, end if. And all it works is you write if, and then you talk about the condition itself. So you could say, for example, if X, well, in fact, we can go over here and look at this one. If entry equals A, and I'm hoping the 3 of you here, 4 of you here now, welcome. I'm hoping the 4 of you here have figured out the difference between equals and double equals. So if you've got a double equals like this one here, it means you're comparing this side of the double equals to this side of the double equals. So in other words, entry is a variable and you're comparing it with A, which would be a user input. So someone's input A and you're comparing it with entry and saying, if they've entered that, okay, then you've selected A. Else if the entry is the same as B, if someone's typed in B, then print you've selected B. Else print unrecognized selection. So the anatomy of this usually is that your first condition will start with an if. If there are only 2 conditions, you'll end it with, so if this is the case, then do this, else do that. If you've got 2 options, you actually don't need this line of code here at all. You don't need that. If you've got two different options, you just don't need that, okay? Else if entry equals B, then do that. You don't need that. You can just do if entry equals A, then print you selected A, else print unrecognized selection. However, they sometimes give you more than 2 options. So if there's more than 2 options, then you add as many of these else ifs as you need to, okay? So if you need to add half a dozen else ifs sort of nested, they won't do it. They'll do a maximum of 1 usually. They don't go beyond that. So that is the anatomy of the if statement. And again, sometimes just writing the word if will get you a mark. If, end if, and put some code in there. And it's just, we're now at the point where maximizing everything you can from this is just so important. Because this paper, it's about trying to harvest marks wherever you can. Okay. That is our if statement. Now, this one is again selection. The construct we're looking at is selection, and this is called switch case. Okay. Now you can see this does exactly the same thing as the previous one, and the anatomy is that at the start of it you write switch, and at the end of it you write end switch, and then you do case A, do this, case B, do that, case C, do that, case D, do that. And you can see actually this is a far cleaner way of doing an if statement than doing an if statement, a cleaner way of doing selection. When you've got, so if you've got 30 or 40 different options, switch is so much easier because you've literally just got to do case A, case B, case C, case D. And then the default here, this works as the same as the else in this one here. It works in exactly the same way. So the else and the default are usually used to pick up errors, to pick up user error. So if someone has to type in A, B, or C, you can then interrogate, question the variable and say, if someone's typed in A, you've done a user input. So you've gone to, let's go back up to here. You've done a user input and you've said, enter option A, B, or C. So option equals input, enter A, B, or C. Okay, and you can call it option. Option equals input, so that's the option there. So we've done that. We've got a variable called option, and we've written in here a message saying either enter A, B, or C. So then we've got, if we go to our selection here, or A and B, which is what it is here. So if you put in A, you can print use. I mean, this would be a pointless program. You understand there'd be no purpose to this program at all, other than someone typing in A, and so then you get a message saying you've typed in A. Not very helpful. But the point is, it's a building block. Okay, so they should only have typed in A or B. But if they've typed in something random like Z, it'll say we don't recognise your selection. Okay, and so the else or the default is used to catch those. Don't worry about learning the code for switch case because you don't have to use it. You can just use an if statement. But they can put this in an algorithm, so you need to know that it is selection. It's the same as an if statement. Any questions, just let me know. Okay, iteration. We've got a couple of flavors of iteration, but I'm going to look at while because, again, you can use different types of iteration, but while will be perfect for your needs. Okay, so let's start here. Now, in the previous one, just go back to here for a second. In the previous one, we said, is there a decision with more than one possible outcome? So you've been through your algorithm, okay? And this is about building algorithms, yes? So you're going through it, and your first question, is there a user input? Yes, we've talked about what to use. Do you need to declare variables, and do they need to be initialized? Do that. Next thing, is there selection? Is there an if statement there? Are there options where there's more than one different thing that might happen depending upon something else? Use an if statement. And if not, there's a chance that it's going to be. Your next question is there a decision with more than one possible Sorry, I'm going the wrong place. Let's go back to here. That was selection. Okay, here we go. This is where I am now. I'm on iteration. And this is called a condition-controlled loop. Think about your greenhouse. You will set the greenhouse. I've got no idea what temperature greenhouses are set to. I've killed every plant I've ever owned. But let's say 20 degrees. Okay, that could be a plant killing or a plant too cold temperature. I've got no idea. But let's say it's 20 degrees. So you could set the heater to turn on when the temperature hits 20 degrees and turn off if it goes higher than 25 degrees. Okay, so you could use a while command to do that, all right? So while the condition is this, then do something. Now, what's really clever about while, I think the best way of describing it is to look at this. I don't know whether you can remember a past paper question where it was about an electronic voting booth where so the voters would go in and you'd write an input message to say, please enter A, B, or C, and you might store that in a variable called vote. So vote equals input, please enter A, B, or C, okay? And then the more challenging part was that it said, it asked you that if somebody entered the word end, then the entire program will stop running and it would count the totals. So this is an example of when you're going to use a while loop. So if there's something that happens that's going to stop the program from running and then make something else happen, again, subverting that sequence where it goes 1, 2, 3, 4, 5 through the code, this is what you would use. And the way you would often do this is you would put this very high up, sort of early on in your algorithm. Just be wary that if you want to initialize variables, initialize them before the while loop, because you don't want your variables to be set to 0 each time that code runs, or else you won't get the results that you want. So say it's a total, it's a running total. You want total equals 0. Once you've sort of done your input, you then initialize and then do your while loop. So notice here we've got while entry not equal to A, then please enter A. So this piece of code can only be escaped when somebody types A. And again, that in itself is a useless bit of code, but you can see how this for a password would be perfect, because you might be looking at a text file for where their password is, and until their password equals whatever it is, then they can't get in, okay? And again, the anatomy is you've got while this condition is true, then do that, and then you write end while. So very often, these guys here, this first line is towards the top of your algorithm, and this one is towards the bottom. They're quite hard to figure out. So what you're looking for is that do things repeat until someone does something, until it's and that word until, which is helpful. So you're looking for for an if statement, you're looking for until. Do this until. Okay, that's going to be iteration. So recognizing iteration and then putting while, and you might get a mark just putting in while, end while, okay? So obviously they vary it, but that's probably as good a bet as any. Okay, so that is our condition controlled loop. That's our greenhouse, okay, or keeping your swimming pool to a certain temperature, all right? Now we've got, and I think this one's a bit easier to spot, and this is the question. So we've done selection, we've looked at if statement, and we looked at switch case, okay, and now we're looking at iteration and the two parts of that. And the other part is we've looked at a condition controlled loop. We're now looking at a count controlled loop. So when you read the question, is there some indication that it's going to happen 5 times, 4 times, 3 times, 10 times, 12 times? So if it's going to happen a certain number of times, we're going to use this piece of code here. So in real life, a count controlled loop is a Formula One Grand Prix. It's a football match where they will play 90 minutes plus injury time, and then it runs, okay? Actually, a while loop could work better. While referee has not blown final whistle, do. Do you know what I mean? So if you know it's going to happen a certain number of times, they'll use this. Now, because they often struggle to write questions that have this in the question, they're more likely, and again, this is only because I've looked at hundreds of past papers over my time, you're more likely to be asked for this discreetly elsewhere in the paper. That's usually what they do. However, they might, just because I've said that, they might have written some kind of question that says, John's going to do this 10 times, right? It's going to print this 5 times. How would you do it? And this is what you do. So the construction of this code, or the anatomy of this code, is as follows. The I here stands for iteration, and iteration means how many times it's going to happen. So, for example, the iPhone that I've got here, this is the 14th iteration, the 14th version. So it means that things go round and they keep getting repeated. So when a product's made, you have different iterations of it, so it's improved over time. That's why it's I there. So from iteration 0 to, and this is how many times it's going to repeat. Now, don't forget, this is 0, that we start from 0. Sir, will you go over gates? Ooh, let me try and get to that. Hang on a second. How do I get out of here? Here we go. Prabby, yes, I can go over gates. And I'm aware that I didn't do this last week and I was ill the week before. So I will go over gates. And in fact, I will possibly get you guys to do a Google form, but I can do gates. And I might do an extra one. I might do an extra couple, but yeah, I can go over gates. like not and or gates. I don't have it here with me now. I'd need to faff around to find it. But yeah, Prabby, I will do that. Whose class are you in? And I'll come in and have a chat with you. I'll need to figure out whether I'm teaching at the same time. But listen, I'm happy to put on as many of these as you need to help you. It's not a problem, okay? So here is the anatomy. There's that you write for I equals 0 to however many times it is. Do something. That's what will happen. And then you say next I. And just in case you're not clear, the job of next I here is to... Where's my little thingamy-bob? It's here. The job of next I means that this returns it back up to here. So this loop is continued. So for example, I 0 to 5, it'll go to here, it'll print hello. Then it becomes 1, it'll print hello. 2, print hello. 3, print hello. 4, print hello. 5, print hello. And then it exits this piece of code and it runs the next bit of code. So again, another example of how this construct, which is iteration, and this is a count-controlled loop, you're able to subvert the you're able to subvert the sequence that normally happens. Okay, Miss Green's class, Prabby, I'll find out when you're in there, and I will kind of have a chat with you guys, but I will put on an extra one of those for you on logic gates. Yeah, I think, okay, that's fine. No problem. If anything else occurs to you, let me know. Logic gates, is that your biggest fear, logic gates? I think people often find it hard to produce the diagrams from the... so when you've got P equals A, not B or C, those sorts of things, okay? People find that quite hard, so we can do that. Right, trace tables. Trace tables are very easy to do, but only if you know what you're doing. So what's the purpose? And the reason I have put this here is that I've just finished marking the Year 10 mocks, and this was a question in there. Come on, rectangle, where are you? Here we go. This was worth 2 marks, and they asked the question, what is the purpose of a trace table? Sometimes they will get you to complete a trace table. They'll give you an algorithm and ask you to complete it, but sometimes they just ask you for a definition, and there are 2 marks for this. Trace, okay, the purpose is to track, the trace shouldn't be there, is to track all possible inputs and dependent outputs. So pretend that I hadn't by mistake left, go away. Imagine that I hadn't by mistake put that word in there, trace, okay, we don't want that. Oh, come on. Where's my straight line? There we are. So imagine I hadn't put that there. It is tracking all possible inputs and dependent outputs. Finally, I'm getting rid of that. Now look, all possible inputs, tracking all possible inputs was worth 1 mark. And then it was the dependent outputs. Because if you'd said track all possible inputs and outputs, you wouldn't have had the mark. The point is the outputs are dependent upon the inputs. All right? So it can look at the inputs and it's looking at those for the outputs. So what outputs are dependent upon the inputs? Okay. So the algorithm below contains a simple loop for I equals 1 to 4, output I times 2. The thing to remember is that you only update the trace table when the value changes. So if the value doesn't change, you leave it. You're only putting in the boxes where the value changes. So say, for example, it goes through and the value stays at 2, you don't write in 2. It's only when the value changes to 3 or 4 that you will then say on which line number it would happen, okay? I think it's quite challenging doing trace tables, but it's worth having a bit of practice. And I can give you some past papers on trace tables, but they're quite straightforward. Again, when you look at this paper, there are so many things that really don't require you to write code. They just require you to understand some principles. So a trace table is to make sure your algorithm works, really. But that definition up there, apart from the word trace, that is your definition of the purpose of a trace table. Good. Common errors. They will give you an algorithm, usually quite a simple one, and they'll put 2 or 3 mistakes in it, okay? And you've got to find the mistakes, number one, and you've got to say whether the mistakes are syntax errors or whether they're logic errors. Now, syntax errors are quite easy to spot because syntax errors really are spelling mistakes in the code. Someone has spelt one of the special words incorrectly. So there are those reserved words which are used for writing code, like print, input, okay, those sorts of things. So, for example, I think they've used this 2 or 3 times now. This would be a syntax error. So it's like a spelling mistake. It's what you'd expect. Autocorrect to pick up, spell check to pick up in a Word document, right? It's when you spell something right. Logic errors is more like a grammar mistake, because a logic error, and by the way, a syntax error, it's worth mentioning this, a syntax error will stop the code from running. So, for example, if you spelt print, P-R-I-N-N-N-T, the code would probably crash. It might not crash, but it probably would. It would most likely stop the code from running. A logic error, on the other hand, is in some ways a bit more dangerous because your code will still run. So a logic error, I think, is best thought of as being a grammatical mistake. So you could say we've got there, and there, haven't we? Spelt 3 different ways. English is horrible like that. So think about a logic error, which could be quite important. That, say, for example, if you were writing an algorithm that said users must be taller than 1 meter 40, okay? So if this was in the code that to get on the ride at Thorpe Park, you've got to be taller than 1 meter 40. If they put in, rather than a greater than, they put in a less than symbol, you would turn a fun roller coaster into an execution machine because you'd be putting people on it who are definitely too small for it. So you have to look more closely at the code. Now, the reason I've put the greater than and less than there, and obviously this one is greater than because it starts big. That's how I remember it anyway. And this one starts small, so that is the less than, okay? Kind of important. So rather than creating a roller coaster which simply kills people, this would be an example of a logic error that it'll still run, but it'll produce unexpected results, okay? So sometimes they will say, what is the impact of a syntax error? Well, the syntax error means that the code will probably not run. The code will crash, okay? A logic error, the code will still run, but it'll give you unexpected results. It'll give you garbage. It won't give you the right answer, okay? So that is... and logic errors have been responsible for a lot of things going wrong. Ships sinking, buildings falling down. Think about logic errors, putting the decimal point in the wrong place when you're calculating how much sand goes into a concrete mixture. It's quite a big deal, isn't it? So that has happened many, many times. So those are your common errors. Right. We're into quiz time. So I think I emailed you guys that, let me try and find it here for you. Hang on 2 seconds. Do a bit of fiddling around on the hoof and try and find this for you. Let me get out of here and see if I can find this for you. Where have I got it? My little pseudocode document. Come here. Where have I got it? I have got it. Oh, I know. I can just do this. Here we go. Calculus. Here we go. This is what I write the... I'm making this nice and big so you can see it. Hang on 2 ticks. Let's go big. There we go. Let me get this a bit smaller so you can actually see what's going on. Just give me 2 seconds. Stop faffing around here. Come on. 30%. Is that going to work? Yay, look at that. That's probably too small for you. Let's leave it here for the time being, right? So with this one, this is what I've tried to go through with you today, all right? And it's a step-by-step guide trying to solve algorithms. And I gave you a whole bunch of algorithms this week to look through. And I just recommend that you sit down with this little guide and see how many marks you can squeeze out of the algorithm paper, okay? Whoa, that's gone massive again. So that's what I'd like you to have a go at, is see if you can figure out how to run this. So obviously, just like code, this one starts at the very top, where we're doing start up here with our terminator, getting ourselves a mark. I did a decomposition job on here. Hope you appreciate this. And then I looked at the order in which you should do things. So your first question was, does the user input any data? If the answer is yes, there's your code. Have you got to make some variables, declare some variables? If you do, you write name a variable equals whatever it is, okay? Then, is it an if statement? Is it a for I loop? And if it's not, the chances are it's going to be, oh, I need to get rid of that. The chances are it's then going to be going down to here, a while. You've actually got a couple of flavors of that, which I've not gone into today. You've got while and you've got do. And the difference is a while statement over here. This checks the, this checks at the start, and this one checks at the end of the algorithm, okay? To be honest with you, using either is fine for you. And in fact, many coders just stick with using one anyway, because you can achieve the same thing with both. And then, of course, at the end, you just do the outputs down here where you're going to use print. So that really is the programming course in 30 minutes. That is what you need to try to focus on doing, okay? All right, quiz time. Shall we see how we do? Where are we? 45. We've got a few minutes. Let's see how you guys do. Oh, I've given away the answer. That's such poor skills. Let's go on to the next one. The answer was 6, by the way. Now then, what about this pseudocode? This one is too hard because it'll take too long. Let's go to here instead. Here we go, an error. What type of error is in here and where is it? Can anyone figure it out? I'll give you a clue. Oh, my picture's gone. My camera's run out of battery. While you have a look at that, I'll pop another battery in. See if you can figure out what the error is. And they often ask you what line's it on and what's the error. I'm just going to stick a battery in my camera. Hang on. I'll give you a clue. You've got to read quite a distance through it. And we're back in the room. Hurrah. So, my question of can a battery last 2 live streams has been answered. It is no, it can't. So there we are. Any ideas? Ooh, Daniel, you are a superstar. It is a syntax error on line 7. What a good egg you are. Yeah, I made you read all the way through it. That was unnecessarily mean. Yeah, so it is. It's down here. Let's have a quick look. It is here. It's obviously print. That's your syntax error. And then you've got to look through and think, is there a logic error? But there's not. It's a syntax error. Okay, a quick flowchart question, something else they can make you do. Make it sound like a prison camp. This is a flowchart question. If you input 38 into input speed up here, what would the output be? Question mark. Prabby, you were absolutely spot on as well. Well done. That is outstanding. Yeah. Make sure you revise the IDE, the Integrated Development Environment. Really important because they've done 8-mark questions on that in an 80-mark paper, a tenth of the marks on an IDE. So easy to learn as well. I'll go through that as well with you. Ooh, I was sleeping while I was having a. It'll sit within limit. You guys are good. I think that deserves at least a round of applause. Okay, within limit. What superstars you are. Okay, look at the flowchart. Some shapes are missing. How many of the shapes should be input-output parallelogram boxes? How many of the shapes should be input-output parallelograms? Don't forget, inputs and outputs are parallelograms. How many do you think? Slightly tricky. Daniel, is there anything on your mind in terms of the upcoming exam and areas that you're concerned about? Probably mentioned the logic gates. Is there anything that's on your mind? Oh, crumbs. 3 and 2 or 3. Prabby's hedging her bets there. The answer is 4. You were close. That was tricky, though. Okay. Let's do a few more. In a flowchart, what shape would you use around the phrase, does the password contain a number? Would it be a diamond, a rectangle, or a square? Well, it clearly ain't a square because we don't use squares, do we? So it's A or B. What do we think? Prabby and Daniel, what do we think? Is it A or is it B? What do you reckon? Ah, how do functions work? Yeah, do you know what? While you're figuring that out, because I think I might have some function stuff here. Just bear with me 2 seconds. And let me see if I can find my functions stuff. Because I might be able to do that for you now. I'll have a look and see if I've got logic gates too. Give me a second. Cognitive science. You both said A. You're geniuses. Well done. There is an evil laugh for you, which is totally unnecessary. What about? Oh, we are onto this. Right. Let me see. Yeah, functions. Let me see if I can find something on functions for you here. I was planning on doing functions next week. No, I've got that on my work computer, so I can't do it here. Okay, but I will do, well, because you two have turned up, and I'm very grateful you have done, because it's really nice when people are here. I will do functions and I will do logic gates next week, okay? And if you two, if anything occurs to you that you're really struggling with, let me know before next week and I'll get those done. But I'll do functions, logic gates. Would you like to do a bit of algorithm in practice sort of thing, looking at a few examples and having a go at that? Have a think about it, okay? And we'll do that. So I will figure that out for you for next week. Okay? So track me down in school. You know where I am. I'm head of year 7, so you know where the year 7 office is. Just come and find me. I'm in ridiculously early in the morning, usually from about 7 o'clock. So if you come to school 10 minutes early, just come and find me in the year 7 office, okay, on the edge of the playground there, and I can have a chat with you. Okay, guys? Daniel, are you in Miss Green's class as well? By any chance? Are you both in the same class? I can look down here because it comes through quicker. Let's have a look. Doesn't matter. I'll figure it out. I can find out which class you're in, and I will I'll have a chat with you. All right, guys. So listen, have an amazing where are we? Wednesday, and I will see you next week. Thanks for coming, and just little and often. You're in Mr. Moller's. Okay. All right, Mr. Mollers, that is fine. So I need to figure out whether we're teaching at the same time or not. I'll have a look. All right, Daniel, so I will speak to both of you, but I will do functions next week. I'll have a go at some algorithms with you, and we'll do logic gates for you, Prabby. All right, guys? I'll see you in a week's time. Have fun. Take care. Bye-bye. Finish.